Hi everyone, we're going to continue our discussion on polar double integrals. Here we'll look at an example of finding volume of a solid bounded by z equals 0 and the paraboloid z equals 1 minus x squared minus y squared. So first, let's see what this paraboloid looks like. So paraboloid, the shape of paraboloid is you have this circle over here and you have two giant parabolas. It's kind of intersecting on these two axes. Hopefully the image makes sense here. And as you can see, when x and y is 0, z is 0. So you have this point 0, 0, 1. And z equals 0 is going to be the xy plane. So when you're on the xy plane, you get a circle. And this circle is x squared plus y squared equals 1. This is when z equals 0. So what we have here is the volume, which will be given by the double integral over this region of 1 minus x squared minus y squared dA. And immediately, because we have a circle, the idea is that we are able to use polar coordinate. So we can rewrite this in polar coordinate. Now the nice thing, the moment you rewrite this in polar coordinate, something really nice happens, which is you will notice that 1 minus x squared minus y squared is actually just 1 minus r squared. And you have r d theta, and this is a very easy integral now. All you have to do is make sure you have the right limits. R goes from 0 to 1, and because we are taking finding the volume, which means we're going all the way around, this is 0 to 2 pi. So basically you have a repeated integral 0 to pi, 0 to 1. You have r minus r cubed dr and then d theta. So you get 0 to 2 pi. You have an r squared over 2 from 0 to 1, and then r to the 4 over 4 from 0 to 1, and then a d theta, which is 0 to 2 pi, 1/2 minus 1/4 d theta. 1/2 minus 1/4 is 1/4, and theta from 0 to 2 pi gives you 2 pi over 4 or pi over 2. Now doing the same over general integrals is possible, but you will end up with a pretty complicated and involved integral instead of a very simple polynomial in R that we did in this case. This brings us to another result, the last result for polar, which is if f is continuous on a polar region of the form. So what is the difference? Well, the theta is between alpha and beta, but r is between some function of theta. So think of this as the general region for regular double integrals. Then the only thing that changes, this remains the same, is that the limits have to be in terms of theta, so that when you perform the second integral, everything is in terms of theta instead of there being r and theta. So let's look at an example. So four-leaf clover, this is something you learn how to plot in a previous class like Math 140, or probably you visit this in other calculus classes as well. But the equation of a four-leaf clover is given by r equals cosine 2 theta, where the leaves are formed because of the 2 theta here. And this is what the graph of this polar curve looks like. Find the area closed by one loop. So we're only interested in the area formed by this one loop. Between theta, the values of theta are given to us, which is pi over 4 and negative pi over 4. And r is between 0 and 2 cosine theta. What does that mean? Well, here's the point 0, and on this boundary, r is cosine 2 theta. So we have r dr d theta. Why is that? The function itself is 1. Because whenever you're finding the area, if you take the distribution of mass as just 1, then you get the actual area, right? So it's 1 times the element, which is dr d theta. The only thing changing here is r goes from 0 to cosine 2 theta here, So think of it as going outward like that, radially outward, and theta goes from negative pi over 4 to pi over 4. The first integral, which is in terms of r, will give 1/2 r squared, 0 to cosine 2 theta, which gives a 1/2 cosine squared 2 theta, which again, you'll recall, as I mentioned earlier, is sine squared and cosine squared theta, or 2 theta, or 3 theta, or 4 theta, are pretty common integrals, so you should be comfortable solving for these. For this, we will use, so remember, cosine 2 theta has various forms, one of which is 2 cosine squared theta minus 1. But here, we are working with cosine squared 2 theta. So if I want cosine squared 2 theta, I will have to replace theta by 2 theta. If I replace theta by 2 theta, then this here will become 4 theta. So cosine squared 2 theta would actually be cosine 4 theta plus 1 over 2. So this becomes 1/2. Originally, that was there from the integration. Another 1/2 that has come from this half angle formula, double angle formula. D theta from negative pi over 4 to pi over 4. You get a 1/4. The first one becomes a pi over 4 minus negative pi over 4. The second integral becomes a sine 4 theta over 4 from negative pi over 4 to pi over 4, which again, that's going to be, when you plug in pi over 4, 4 times pi over 4 is pi, and multiples of pi, sine is 0. So this becomes 0, and you end up with 1/4 and a pi over 2 or a pi over 8. So if you were finding the area of all 4 leaves together, then it would just be 4 times pi over 8, which is half pi. That's because these are symmetric. So whatever is the area of one of them will also be the area of the other. All right, so that's where we will end this particular section with polar coordinate system and doing double integrals in polar coordinate system.